with our second example, RLC circuit. So what is transfer function? Transfer is equal to GS equal to V out S over V in S. Okay. S domain output divided by S domain input. That one is our transfer function. So our input is here, V in input. This one is V out. Okay. So again, we can use KVL here. KVL. Kirchhoff voltage law mentioned that the total voltage in a closed loop equal to 0. Okay, KVL. Total voltage in a closed loop equal to 0. So what kind of voltage we have here is minus V in plus we have I, current, RIT plus L GI over DT. Okay, plus. So now we have we call this one capacitor. So what is voltage for capacitor? We know that voltage for capacitor is equal to V capacitor equal to 1 over C integrate I dt. Okay. This one is voltage for capacitor. So plus 1 over C I dt equal to 0. Okay, KVL. This voltage plus this voltage plus this voltage plus this voltage equal to 0. Yeah, we have this voltage is VI, this one, this voltage. Voltage at R, RIT. Voltage at inductor, L di over dt. And voltage at capacitor is equal to 1 over C integrate I dt equal to 0. Okay, this one is okay. Now is V0. Okay, V0. Okay, here you know that V out is equal to V at capacitor. Okay, this one is parallel. Parallel. So that means V out equal to VC. Okay, V out equal to VC equal to 1 over C I dt. Okay. So now we rearrange it. Okay, VI equal to RIT plus L di over dt plus 1 over C integration I dt. Okay. Second one, V0 equal to 1 over C integration I dt. Dekat sini okay tak? So now next we change to S this one is as T domain. T domain. So now we change to S domain by using Laplace. Okay, Laplace semua ni lah. Okay. So first we Laplace V in equal to Laplace RIT plus Laplace L ZI over dt plus Laplace 1 over C, 1 over C I dt. Okay. This one also we Laplace it. V0 equal to Laplace 1 over C I dt. So far okay? From time domain to S domain okay tak? Any question?
No, Prof.
No, okay. Now I will go. Yang tadi, yang student tadi okay tak ni? Tadi start kat sini kan? And dia start kat sini. Okay, first step, we just using T domain, we using time domain, we using KVL here. So by using time domain lah, we derive the equation using time domain, then we get this equation. Okay, this equation if time domain for this loop, and for this one, this equation. So we have two equation. Okay, equation number 1 and equation number 2. Okay, equation number 1 for KVL, this KVL loop. Equation number 2 for this loop. Next, we just rearrange it. Just rearrange V1 VI equal to blah 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 blah, and this one. Okay. Okay. The next step is we convert from T domain to S domain by using Laplace transform. Okay. We Laplace for each component. Laplace VI, Laplace this component, Laplace this one, and Laplace this one. Okay. Why we Laplace it? Because we want to convert to S domain. Okay. Is it clear? So now, for this one, we become V in S domain equal to R I S domain plus Laplace for L di over T, L S I S domain. Okay, plus for this one, when we Laplace it, what we get is Laplace integral is equal to 1 over CS. 1 over CS IS. Okay. Okay, at this side, okay, this is number 1. Number 2 is VS equal to 1 over CS IS. Question number 2. Okay. If you have any question, just stop me. This one is V out, V out. V out. Okay. Finally, so now we have V in S domain and also V out in S domain. So we know that the transfer function is equal to output S domain divided by input S domain. So what we get is V 2 divided by 1. Okay, 2 is here. 1 over CS. Okay, now we cancel IS lah, cancel terus lah. Boleh kan? 1 plus LS plus 1 over CS. Okay? This one is after cancel IS lah. Okay, so now we times all with CS. Atas kita cancel 1. So R times CS S CR plus CS LS. So S power of 2 CL plus 1. Okay, ini again. V out over V in. This one is GS. Okay. Okay, this one is transfer function for this circuit, for this circuit, transfer function for this circuit.